All right, here's a great stoic question. 15 mils of a 3.3 molar solution of sodium phosphate reacts with 20 mils of 0.27 lead nitrate. What's the concentration of phosphate ions left in solution after the reaction is complete? Yeah, it'd be nice if it was zero, eh? That'd be easier. And phosphate ions. Okay, let's write a chemical equation first. So I have sodium phosphate, Na3PO4, plus lead 2 nitrate. So that's lead nitrate 2. Okay, the double replacement thing. So I'm going to get sodium nitrate and lead 2 phosphate. Okay, so this needs a 3 and the phosphate needs a 2. Is that right? Yep. Okay, let's balance things. I think I need a 3 there for lead. That gives me 6 nitrates, so I need a 6 here. So over here I need a 2 to get 6 sodiums, but that gives me 2 phosphates, which I have. So I think that balances everything out. Okay, so now they give me information about sodium phosphate. So the volume is 0.015 liters, and the concentration is 0.30 molar. They also give me the volume here as being 20 liters, and the concentration is 0.27 molar. And they say, what's the concentration of phosphate ions left in solution after the reaction's complete? Well, I think I've got to do some more work here. Because I have phosphate here in the reaction, the reactants, and I have phosphate here in the products. But they say left in solution, so that sort of leads me to think that maybe this one, when you do the chemical reaction, is a solid, and so there won't be any phosphate ions coming from this in solution. So they would only be this one. But let's confirm that. Let me bring up a chart just a sec. Okay, so lead phosphate. So phosphate is here, and lead is not in group 1, or it's not that, so it's down here. So yes, that means it's a solid. So that's a solid, therefore it won't be giving phosphate into the solutions. It'll only be this one. Now, if it looks like they gave me too much information in the question, so I think it's not too much, but they give me information from here I can get moles, and from here I can get moles from both of those. And typically they only give you moles of one, and then you find moles of the other one. And so it's a limiting reagent question. So I guess what I'm asking, or what they're going to be asking here is, does all of this stuff get used up? If it does, then there won't be any phosphates left. But if I have excess of this, and if this one's the limiting reagent, then I'm going to have to figure out how much of this stuff I have left. Okay, so I'm going to have to do a limiting reagent kind of thing. So to do that, I need to find moles of each of these reactants. So let's find the moles of the sodium phosphate. Okay, so to do that, C is equal to N over V. So N is equal to C times V. So the concentration is 0.3 moles per liter times the volume, 0.015 liters. The liters cancel, and that gives me 45 something. Okay, 0.3 times 0.015, 0.0045 moles. Okay, and that's of the sodium phosphate. So now let's figure out how many moles of the other one we've got, of the lead 2 nitrate. Okay, it's going to be the same game, right? So N is equal to C times V, or 0.0, concentration. Concentration is 0.27 moles per liter times the volume 0.020. So same kind of multiplying, eh? So I'm calling it 54. So 0.0054 moles of lead 2 nitrate. Okay, so I have 45 of that, 54 of that. If I look at the ratio, I need 2 of these for every 3 of those. So in other words, for the reaction to happen, I need more moles of lead nitrate. And I do have more moles, 0.0054 versus 0.0045, but like it's close. I'm not exactly sure. So I like to do the figure out how many moles of the lead nitrate I would actually need if I used up all of this stuff. So let's try that. So if I have moles of lead nitrate needed, that's what I'm doing. So I have 0.0045 moles of sodium phosphate times my mole ratio. So it'll be 3 moles of the lead. It's a pain writing that all every time. Over 2 moles sodium phosphate. Okay, so if I have 0.0045, if it reacts with the other, just according to our mole ratio, let's see what we get. So 0.0045 times 3 divided by 2. 0.00675. 0.00675. So that's how many moles of the lead nitrate I would need if I used up all of this stuff. Okay, but I only have this much. So if I only have this much, that means I have excess of this one. So this is my limiting reagent, and this is the one in excess. So typically what I would do is I would forget this one and just work with this one because it's the limiting reagent. But in this question, they don't ask how much of this stuff or how much of this stuff they need. They say how much of this stuff is left over. Okay, great. So that's a little bit different, harder question. Okay, I need more room. So let's move up a bit. I'm going to move right up to there. Okay, so this doesn't help me because, this number here doesn't help me because that tells me how much of the lead 2 nitrate I would need if I used all of the sodium stuff, the sodium phosphate. So what I need to do is figure out if I used all of this, how much of that is left over. So let's do the same step, but let's do it with the other way. So I want to figure out how many moles of the sodium phosphate I would have left over. So I start with the other one, the lead 2 nitrate. So I have 0.0054 moles of lead nitrate, lead 2 nitrate, times by, okay, where is my reaction? 2 to 3. So in the reaction, 2 moles of the sodium phosphate, that's a 3, react with 3 moles of lead 2 nitrate. So these cancel. Let's do our calculator. 0.0054 times 2 divide 3. 0.0036. 0.0036 that's how many moles of the lead phosphate that would get eaten up if I used all of this lead 2 nitrate. So this gets used up and this gets used up. But if I take a look back, I have that much. So I used up this much, so I'm going to have some extra. Like it looks like I'm going to have 0.0009 moles of the phosphate stuff left over. So let's just do that subtraction. This is a complicated question. So I would have 0.0045 minus 0.0036 moles of of the sodium phosphate left over. Cool. So that would be 0.009 moles left over. But the question said, what's the concentration of phosphate ions, right? What's the concentration of phosphate ions left in the solution? So I have 50 mils of one and 20 mils of the other. So let's write that dissociation equation. So I'd have sodium phosphate would dissociate to 3 sodium ions and 1 phosphate ion. So whatever the concentration of this is, it's the same for the phosphate ions. So the concentration is moles divided by volume. The moles are this one, that's how many are left over. 9 moles left over. Divided by the volume, since I put both those in the tank, I've got 15 mils of one and 20 mils of the other. So it's 35 milliliters altogether in the solution. So I would divide this by 0.035 liters, and that should tell me my concentration. Let's see if it does. Hopefully it's one of the answers. 0.009 divide 0.035. So I'm getting 0.25711428 moles per liter. Let's check sig figs. 3, only 2, 3, and 2. So I need to go to 2 sig figs. So I'd probably round that to 0.26 moles per liter. Okay, is that an answer? It is, yes. I'm calling it that one right there. That's a very difficult question. On a test, I might give you one like that. I would probably ask a question, that's a whole lot of work, eh? I would probably ask a question where it's a basic limiting reagent question and then ask information on one of the products. Like this one would be a good one because I would say what mass of lead 2 phosphate is produced in the end. But then I could ask a further question and say, okay, how much of one of these things is left over? Tough question. Like it.